Algebra 2, target 18. I can extend the properties of integer exponents to work with rational exponents. Today our focus is going to be applying the properties of exponents to rational exponents. And again, rational means we got the fractional exponents. So let's just quickly review these properties. And for a more in-depth review, see target 10. So the properties for any exponent, there was basically 6. If you're multiplying exponents to the same base, you're going to add the powers. Example given here, it's the same whether you do it with whole numbers or if you use rational numbers. 5 to the 1/2 plus times 5 to the 3/2 is the same as 5 to the 1/2 plus 3/2 or 5 squared. When you have a power to a power, you're going to multiply the powers. If you have a power on a multiplication product, you're going to apply the power to both bases or both parts of the multiplication problem. Negative exponents relate to fractions. And then division of exponents to the same base is subtraction of the exponents. And the same thing if we have a division problem raised to an exponent, you're going to put that exponent on both parts of the division. And again, for a more in-depth review, please see target 10. So let's use these properties. We got 7 to the 1/4 times 7 to the 1/2, right? So what we're going to do is we're going to apply the properties. We got two exponents that are multiplied and have the same base. So we're just going to add the exponents. We're going to take 7 to the 1/4 plus 1/2. We're adding fractions, so make sure we have a common denominator. 1/2 becomes 2/4. So we got 7 to the 3/4. Right? It's the exact same thing as when you use whole numbers, except now you're using fractions. And that's so that we can deal with radicals and roots. If need be, you could rewrite this as the 4th root of 7 to the 3rd. So these are both acceptable answers depending on the situation you're looking at. Right? Here's another example. Maybe pause, try it, come back. Right? So here we have a multiplication problem with an exponent. So I'm going to take that exponent and I'm going to apply it to both pieces of the multiplication. So we're going to have 6 to the 1/2 squared and 4 to the 1/3 squared. Make that actually be 1/3. All right? And now after we've applied, we got a power to a power. So we got a power to a power, power to a power. In that case, we'll multiply 6 to the 1/2 times 2 and 4 to the 1/3 times 2. 1/2 of 2 is 1. 1/3 of 2 is 2/3. So we got 6 times 4 to the 2/3. That would be the exponent form. If you need radical form, we'll have 6 times the 3rd root of 4 squared. If you want, you can simplify 4 squared to 16. Right, try this one. All right, so as we take a look at this, we got the same idea. We got a multiplication and we got an exponent. So we're going to apply that exponent to both parts of the multiplication. We'll have 4 to the 5th to the negative 1/5. And 3 to the 5th to the negative 1/5. Okay, so now we got a power to a power. We'll multiply those. 5 times negative 1/5 is negative 1. 5 times negative 1/5 is still negative 1. Now remember, with the negative exponents, those convert to fractions. So this is 1/4 times 1/3. And when you multiply fractions, you go across the top, you get 1, across the bottom, you get 12. Right, try this, pause this one, try this next one. We got 5 divided by 5 to the 1/3. One of them does not have an exponent, or it doesn't appear to have an exponent. What number can we put up there that won't change it? Well, let's put a 1 up there. Now we got a division problem with exponents. When you're dividing exponents that have the same base, you're going to subtract 5 to the 1 minus 1/3. To subtract, you need common denominators. 1 becomes 3/3 minus 1/3. So we got 5 to the 2/3. Right? There you go in exponent form. We can convert that to radical. So we got the cube root of 5 squared, which you could write as 25's cube root. Pause and try this one. Right, this one, got a couple things going on here. You could take the 2 and apply it to both parts of the division. In fact, let's do that right now. We got 42 to the 1/3 squared and 6 to the 1/3 squared. You've got a power to a power. We're going to multiply. 1/3 times 2 is 2/3. 42 to the 2/3. 6 to the 2/3. Now from here, it gets a little bit tricky. Take a look. Both of these have the same exponent. I'm kind of going to take this, where I applied it in, and work it out. I'm going to pull the 2/3 out. So I got 42/6. I'm going to pull out and have 42/6 to the 2/3. And then 42/6, that's the same as 7. So we got 7 to the 2/3. There is our exponent answer. And if you need it in radical form, it'll be the cube root of 7 squared. All right. Try this one. Let's first take and rewrite this as 64 y to the 6th to the 1/3. And now we can take our 1/3. Since we have a multiplication problem to a power, we're going to take that 1/3 and apply it to both parts of our multiplication problem. We'll have 64 to the 1/3 and y to the 6th to the 1/3. Now 64 to the 1/6, if you happen to know that, you can calculate it. 64 to the 1/3 is 4. Here we got a power to a power, so we're going to multiply. 1/3 of 6, 6 times 1/3 equals 6 over 3, which is 2. So we got 4y squared. Try this one. We have a multiplication problem raised to an exponent. So take that exponent and apply it through. So we got 27 to the 1/3, p cubed to the 1/3, and q to the 12th to the 1/3. Now we need to simplify each piece. 27 to the 1/3, that's the same thing as the cube root of 27, which is 3. Here we have a power raised to a power. Whenever you have a power raised to a power, you multiply. P to the 3rd to the 1/3. 3 times 1/3 is p to the 1st, which is p. Then 12 times 1/3 is 4. So we get 3pq to the 4th. Try this one. What we're going to do is we're going to break it up like we did for when we had the exponents. We're going to break it up into the numbers. 14 over 2. The x's, x over x to the 3/4. The y's, and the z's. And z's on the bottom, so I better write it as 1 over z to the -6. Now take each piece and deal with it. 14 over 2, that's just division. Division of numbers is just division, so that's 7. Division of exponents, you need to look at the exponents and subtract them. You don't see it here, but there's a 1. That's the only number we can put there without changing it. So we'll subtract those. 1 minus 3/4 is 1/4. Y to the 1/3 is fine. And what do we do with the negative exponent? Well, the negative exponent is a fraction. If it's already a fraction, we're going to bring it up, and it becomes z to the 6th. All right, last example. What do we do here? Well, take your radical and make it a power. You got m to the 4th over n to the 8th to the 1/4. And then we'll apply that power into the division problem. We got m to the 4th to the 1/4 over n to the 8th to the 1/4. And that becomes power to power. You multiply. 4 times 1/4 is 1, so it's n. Over 8 times 1/4 is 2, so it's m over n squared. So, in summary, we're taking what we did for target 10, which is dealing with the exponent properties. Dealing with the exponent properties, except now we're using radicals.